First things first, the subject of the talk, functional decomposition and the art of functional JavaScript. The title was just meant to bring a lot of people into the room, and it looks like it did that. I have no idea what this actually means. It just sounded like, well, now I have to figure out a good meaning for it, which I wasn't able to do in time for the presentation. So stay tuned for that. I'll put that on a website somewhere. Who here feels like they are, well, let me start this way. Who here is familiar with functional programming? Awesome. Who here practices functional programming day to day? The hands should have probably only gone halfway up.
Yeah.
Who here is a front-end developer? So if you raised your hand before and raise your hand now, you're probably not really being totally honest with yourself. Because front-end developers are kind of tied down to something that's really not functional or, you know, doesn't really blend itself well with functionality, which is the DOM, right? So all of, just for reference, I'm a back-end developer. I'm going to introduce myself here. I'm Scott Leonard. I'm not a professional speaker. I'm not on the JavaScript speaking circuit, that type of thing. I'm just really interested in functional programming, and I really want to, you know, get people excited about it and get people using it the right way and for the right reasons. I've seen a lot of people talking about functional programming, but a lot of the stuff we talk about right now is very tied to a specific language or a specific library or tool set. And I think sometimes the tutorials and the things that we talk about kind of gloss over the importance of this concept in computer science. So I have a master's degree in computer science. There's more authority for you if that fancy title at the beginning wasn't enough. And 15 years of IT experience, not just programming, but also doing server stuff and server administration, DevOps, that kind of thing. I work at ClientSuccess. ClientSuccess is a fun company to work at. If you're looking for a job, come and talk to me after the presentation. But my real sales pitch is this, because everybody says that, right? And if you're not a fun place to work right now for a developer, you're not going to keep your developers. So everywhere's fun, right? If you want to make decisions about what technology you're using, implement it immediately, use the latest and greatest and coolest stuff, if you want to, when you want to, and not be tied down by a ton of management and things like that, come work at ClientSuccess. Because we are very small, and if that doesn't scare you and the other thing excites you, then we're the place that you want to be right now. We're going to grow, we're hiring more people, and we're very excited about new technology. So, functional, why? And I want to kind of get a little bit of interaction here. So, why functional?
Sometimes it can be faster or easier to write.
So, performance?
It's easier to test.
Performance or speed of development?
Both, okay. Depending on what you're doing.
Okay. I heard one in the back here that I liked a lot.
It's easier to test.
Easier to test. Good. We're going to talk about
Maintainability.
that. Maintainability.
Code.
Awesome.
Ego.
Sorry, what was that? Oh, yeah.
Make you feel better about yourself.
Make you feel better about yourself. Sleep better at night sometimes.
Confuse other people that read your code.
Yeah, there's a big one. There's a big one. So
Yeah, job security.
that's good. So who here has written code in a functional way before and had somebody come to you and say, what is this? I don't understand this. I have, right? I try to write stuff, I try to always be very, very strictly functional, pure functions and all that stuff, and people frequently come to me and like, this is nonsense. So here's the three that I wanted to focus on. Reduce logic errors, improve stability, and make it more testable. So the first two, reduce logic errors and improve stability. The logic errors comes in, obviously, you know, when you write your code and you run your tests and all that stuff is great, and then you put it into production and what happens? First time some customer puts some data into it that you weren't expecting, it's like, you know, not good. Improve stability. That kind of ties into the logic errors, but it's not the same thing exactly, and we'll talk about that a little bit. And then more testable. Wasn't sure if testable had an A or not, but that looks better to me. So, Wikipedia, the source of all truth and knowledge in the universe, right? Wikipedia. So, typically I don't like the Wikipedia definitions for things, but in this case, functional programming definition, I thought was awesome. The first sentence in that article, you should read it and kind of go through it, or just wait for the presentation, because I'm going to go through it. But Wikipedia says, that functional programming is a programming paradigm using mathematical functions that avoids changing state and mutable data. And after reading that, I wanted to switch the title of my presentation because that sounds way better than what I came up with. But I want to go through that and figure out what that really means because I think that really is a good definition. So, programming paradigm, not a language or a library. How many people here use some library to enforce functional programming in their code? Really? Only a couple of hands.
Talk to the mic, I can't hear you again.
Oh, I'm sorry.
Thanks.
Can I turn it up or am I just too far away?
It's nice when you get close to it and talk.
Yeah. Like that?
Talk slowly.
Like I have a new girlfriend?
Move your lips a little bit more.
Okay.
Just trying to get close.
All right. I won't move my head. Does that work? So, my question was, how many people here use a library or a language that enforces functional code? And I don't even see the same hands. That makes me how many people here use underscore or lodash? Oh, wait, there's more hands. What's that doing? What's that library doing? That's a library that enforces you to use functional styles. How many people here use immutable.js? Oh, excellent. I like that one, although I don't use it. Anybody use ramda? I wish there were more hands there. That's my library of choice. The thing is, functional programming doesn't require a language or a library. You can do that right now just with regular vanilla JavaScript, and it's because it's a style. It's not really something that you need to enforce with a language, although that does help. So, some of the languages, you guys have probably seen that list before somewhere: Haskell, Erlang, Lisp with a star. Those that are really into functional might know why that is, and Scala. And I'm not going to answer that question either. You have to go Google and figure it out. And functional JavaScript libraries, I named a couple of them already: underscore, lodash, ramda, immutable. And then I found fn and function, which are two other libraries I've never heard of before. These things are popping up, every single day. There's a brand new functional library in JavaScript, which I guess is the rule for JavaScript, right? The only constant is new libraries. You do not need any of those to do functional programming, but it may make your life easier. Like I said before, you can do all this stuff in vanilla JavaScript. And it's getting easier and easier as time goes on to do it in vanilla JavaScript because the community is demanding it. A lot of the changes that they're making in ES 2015 and ES 2016 are going to add more functional stuff to the libraries. So the next sentence is probably the most confusing and the one I'm probably going to spend the most time on. Treats computation as the evaluation of mathematical functions. Ooh. Anybody here a math major in college? Awesome. I was a CS major. How about CS majors? How many people? All right, cool. IS? Don't be scared. I'm not going to pick on you, I promise. I did write your names down.
Good eyesight.
ISIS?
No, you have good eyesight.
Oh, yeah. I call it IS, not ISIS.
Probably good.
Because I didn't go to school in Utah. What? Oh wait, I forgot. I talked too much in between those. Mathematical functions? What? Programming equals math. Is there anybody in here that's not comfortable with that concept? Programming equals math. Yeah, so all the people that invented the concepts that we have today in computer programming were mathematicians. There were people that had PhDs in mathematics. Back when these things were invented, back in the 50s and stuff, they didn't really have a computer science program in most colleges. So they were developing programming languages before really programming languages were used for anything cool or useful, which I think is very cool. Okay, so I tried to make this very simple. F of x equals 2x plus 1. Is there anyone that doesn't get this? Don't be embarrassed, because I'll just go slower and, okay. I'll try to explain it in detail, right? So this is just like a function in JavaScript, right? You're passing in a variable x, and you're evaluating what comes after the equal sign. So, sorry, I think I moved again. You're evaluating what comes after the equal sign. So if you pass in a 3, you're replacing x with 3, right? And the answer you come up with is 7. That's pretty straightforward, pretty easy, pretty basic. We do that same thing in code all the time. Now we're going to introduce a second function. This is where things get fun and tricky. G of y plus 1. It's the exact same thing, right? Whoa, hold on. I don't want to scare you guys. If we were to put a number into that, if we were to put the same number 3, what would the answer be? 4. Nice. See, you guys aren't scared of math. 3 plus 1 is the tough stuff. Emma, I hope you answer that too. My daughter's in the third row, so hopefully she knew the answer to that one. The cool thing with math, just like the cool thing with JavaScript, is that you can pass a function into another function. Yeah? So if you pass g of y into f of x, you end up with 2 times y plus 1 plus 1. Or simplified, that's 2y plus 3. Does everybody, we good? Everybody follow that part? And now if we throw the number 2 into that, we end up with 7. Now if we go back and we look at what we did there, we're adding 1. The result of that is going to be, so we passed 2 in, we added 1, the result is 3. We all remember that the original value when we passed 3 into the first function was 7. And look, magically it just works. So in code, we do something like this, and keep in mind this is real code that works, but it's kind of pseudocode in the way that we're not really passing the function into this, we're passing the value. So just keep that in mind. But f of x, we're going to return the value, right, where we pass 3 into that, and then g of y, same deal. So now if we were to do this, if we were to call g with the value 2 and pass that into f, it would return 7. You guys all are mathematics students. That's awesome. So functions like these are very, very easy to test. And don't let the simplicity of the math in the function fool you. Because there's a couple important concepts that you can reproduce even in very complicated logic that will make this be true. That'll make this just as simple and just as easy to test in all of your code. So we're going back to the Wikipedia definition. Functional programming avoids changing state and mutable data. So we all know what state is, I think, right? State, yeah, of your application, state. Do we all know what the DOM is? DOM equals state. That's one of the, I should have written that on a slide. I'm going to do that for next time. I'm going to iterate on these. So in an object, we can make an object that has certain values, and here I've got an object that's a product, basically. It's a recurring revenue product, it's an active product, and the logo is a blank string, which is not a very exciting logo, but it's probably the kind of thing that I would design, being a backend engineer. And is state a bad thing? Like in our applications, is state bad? No. Is the DOM evil? Well, that's a bad question. Is the DOM bad? It might be evil, but it's not bad, right? It's necessary. It's a necessary evil. It's a thing that we've got to live with. We've got to keep track of what our application is doing. But we've got a problem. And I'm gonna do a little code example here that's going to demonstrate an issue with having state. So I'm going to create a constructor for that product. Okay, and you can see that the same default values are there. It's going to return an object that has those values. And we're going to create a function that does something. You guys can probably already see what's going to happen. And I'm going to show you why the use of state encourages side effects. Does that work? This isn't very conducive for live coding. All right. Okay. So, thank you very much. So I've got a JavaScript file there called sideeffect.js. I include this in all of my real live production JavaScript projects. I named it that so people get scared. Sorry, I didn't mean to do that. And I'm a horribly slow typist, so I'm a little embarrassed about that, so don't make fun of me too much later. So we created those two things. We created a constructor for our product, which we're going to call now, and we're going to make a new product. And when we look at P, we can see, oh look, it got all the default values, that's nice, right? And then I also made a function called test. Now when I run test, what test is doing, I don't know, but it's a really contrived example that's going to return the number 3 for absolutely no reason whatsoever. But you're going to see that if I run test P, it equals the number 3, that's awesome. And so if I write a unit test for this, I can say, well, if I pass in the default values and I get back the value 3, that means my unit test passed.
Your console's a little off the screen.
Oh, sorry about that. Okay. We're still good? Oh, my back hurts. So, we can see that, if we write a unit test for this and we say, I'm going to pass in the default value and I should get back a 3. So you pass in the default value, you get back a 3, everything's good, right? Pass the unit test. Hooray, my code is side effect free and works and it's great. But, for those of you that are watching closely before, you might have seen a problem. Look, now my logo is XYZ. That's bad. I want a blank string for my logo. So even though the unit test passed because the input was one thing and the result was what we expected, it changed a value in that object because objects are mutable in JavaScript. So that's probably a very basic concept. But it's something that we do every single day. And it's a very common mistake that we make. So, having objects like that, and passing them into functions and changing the values in those functions, bad. State impossible to avoid? It might be if you have to work with the DOM. I'm going to bash the DOM as much as possible today. So, immutability is another thing that functional programming looks for, and we just went over what that means. There's no such thing as an immutable data structure in JavaScript. The primitives are immutable, and Daniel talked about this actually in his talk, for those of you that were here. But anything that's an object or a complex thing in JavaScript can be changed. If you pass an object into a function, that function can change it however it wants. And because it's just a reference to that object, everyone else that refers to it is going to see those changes happen. And so the problem with that is that you've got a lot of just, if somebody writes a function and is making changes to your stuff, you can't confidently call that function and think that it's going to return 7. Remember the math example before? Imagine if, as you're running those math examples, somebody suddenly changes the value of x from 3 to 7, and you get back the value 9. That's weird, right? You can write a unit test for that, though, but what if they change the value of g of y? It could be some completely arbitrary calculation that just happens to return the right number and returns the right value, but it's completely different logic than what you expect. And that's really a big problem. So there's some libraries that fake immutability. Immutable.js is one. We talked about that. Some people are using it. And Mori, which I've never used, but actually it seems to, like a lot of people seem to be talking about it lately, so I might have to check it out. All right. And I've got way too much material here, just so you guys know. The other principle that I want to talk about in terms of immutability is determinism. Has anyone heard that word before, determinism? 1, 2, 3, 4, 5, 6, that's like 1% of the room. Awesome. So determinism, what that means is for any one value or any set of inputs, you're going to get back the same output every time. So that means if I pass 3 into that function, every time it's going to return me back 7. That's a deterministic function. So in our code, when we write unit tests and things like that, the unit tests help us to write deterministic functions. So when we pass in a certain value, we're going to get a certain value back. Okay? That doesn't help with side effects, but it's very important to make sure that your functions are deterministic. Oh yeah, I said all this stuff, but I didn't flip the slides. Okay, how can we use this? Start now. For those of you that didn't raise your hands when you said you're trying to program functionally, this isn't something that you need to wait to do. You don't need to make a big technology shift and say, manager, boss man, we need to switch to functional programming. You don't have to do that. Start studying now, learn about it. 35 minutes is not enough time to go over all this, and there's a lot of stuff out there for people. There's words and terms that I had in my slide deck that I had to cut out because we don't have enough time to go over it all. Currying? Currying? Yeah? I'm going to give a round of applause for currying. Everyone likes currying. Thank you. to talk about that. That's a whole presentation in and of itself. But start now by avoiding state changes in your code. Avoid the contrived example that I set up. Make sure that you're not changing the logo to XYZ. Reduce your variable scope. Okay. Are people here using ES 2015? Yeah. Let. Everybody know let? Const. Const is awesome. Const can trick you, but it's awesome. So if you use let, and I have oh yeah, do you really need an assignment operator? You should ask yourself that all the time. Do I really need to be creating a variable here? Usually the answer is no, just so you know. The more variables you create, the more state you create. And declare variables inside your function, don't share values. Here's let. I didn't do an example of const, but this is directly from the MSDN library examples. So this let test, I'm pointing at my screen as if you guys can see what I'm talking about. Let x, this isn't any better, is it? Let x equals 31. If true, let x equals 71. The cool thing about let is that it is block scoped, meaning that you're declaring a variable x that has the exact same name, but it's not interfering with the one outside of the brackets because you use let instead of bar. So then when you console log that one, you get 71, and when you console log the other one, you get 31. It's very cool. It helps you to limit the mutability of those variables. So it helps you to keep your code, the things that are mutable, really well contained. Immutable when possible. I've talked to death about immutability. And objects are mutable. Be careful. Eliminate side effects. Whoa. I hit the end of my slide there. So, and eliminate side effects. We talked about the side effects as well. We want to try and get rid of anything that makes changes to those objects, makes changes to whatever scope you're running your code in. All those things will help you to make it more functional. And I actually want to talk a little bit about functional programming with you guys. I want to see if in the last, I think I have 5 minutes, 10 minutes? 10 still? Cool. I want to talk and see what issues you guys have run into trying to use functional programming in your daily life, like in your daily code and the projects that you're doing. Has anyone tried and run into problems implementing functional styles? Nobody has.
Well, composition can get interesting.
Okay. What do you mean by that?
Determining the granularity at which to decompose, and then recomposing and redoing that for recomposition is challenging.
Very, very challenging, right? So the question was, or the comment was that composability can be a problem. It can be confusing to decide how small to make your functions, basically. The functions that I wrote up here for the example are very small, very compact. But when you get a lot of code, when you have a project and you've got a big procedural block of code, it's really hard to decide which of those things should be cut off into functions that you can reuse, and which of those things should stay in that big block. Is that kind of some of what you're saying? Yeah.
So at my company, we have a bidding server, so people can make bids, and it informs others, and then a new bid comes in.
Yeah.
How do you suggest avoiding state to determine whether, for example, the new bid is higher than the previous high bid?
Right. So there's an example where I don't know if you can avoid state in that situation, right?
Repeat.
I'm sorry. He said that they have a bidding system where one person can make a bid, but then another person can also make a bid, and you need to compare those two bids to each other, basically to see who made the best bid. It's simplified probably, but. And that's an example where I don't think that state can be avoided. I said earlier, can state be avoided? Maybe. Sometimes it can, sometimes it can't. I mentioned the DOM. It's impossible to do there almost. I'm a backend engineer, so state in the database is a huge problem because the database is a giant state machine, even worse than the DOM, right? Your database has tons of state. I'm going to say that there's one concept, and I'll let you answer too, but there's one concept that I've run across that is trying to answer that question right now, and I think people are trying to solve that exact issue, and that's by making things, putting a date on them. And so there's certain databases like Datomic. Has anyone used Datomic or heard of it? 1, 2, 3. Awesome. All right. So hopefully I increased awareness there of another database that's trying to solve that problem. But what they're trying to do, and that's made by Rich Hickey, who's the guy who created Clojure. Clojure? Yeah. All right. So, and he basically is trying to make a database that is immutable, where you're keeping track of state, but really it's not creating new records. It's not changing records. All it's doing is appending a time to it. And so you really have a different record for each of those things. Does that kind of make sense? Not really? All right. Okay. We can talk a little bit. But did you have something that you wanted to?
Well, sort of. You mentioned that it's important to limit. You mentioned it's important to limit state and the scope of where that state goes. You can use in JavaScript. You can use closures to limit the amount of state you can expose it.
Yeah. Yeah, that's excellent. And using that along with let, helps you to reduce the scope of those changes. Any questions about what we talked about with functional programming?
If there is a private function, how you test that private function?
Sorry, I had trouble hearing. Did you say a private function?
Yeah, if there is a private function, and if you want to write a unit test for the private function, how do you write it?
Well, so I assume you're talking about in Node modules, right?
Anything in JavaScript.
So JavaScript really doesn't have the concept of private.
You can. I mean, if you have a function that was a return statement, it's a private function.
Right. Oh, you mean like a closure, like the returns a function? So yeah, that's what we were saying up here is that you can't really unit test that. Well, that's probably a more complicated question that I can answer really quickly. But we can talk about that a little bit more. So, any other questions?
I'm just curious if anybody's using the functional language Elm, or if they've heard about it.
Yeah, I've heard of it. I've heard of it, and I looked at it, but I haven't used it.
Okay.
It wasn't popular enough for me to include it on my languages.
No.
It's growing a little bit, though.
Yeah, I started messing around with it. I thought it was pretty cool, and I was curious if anybody else had it.
Yeah, it's very cool.
So I've heard that JavaScript isn't necessarily optimized for functional programming, the tail recursion.
Tail recursion, yeah.
Anyway, has anybody actually run into practical limitations in the database? Like, where does that bite you?
Yes. So do you want to answer that? I've got an answer
I think
too.
Trevor's got the answer too.
Yeah.
I was just going to say ES6 does have
Yes.
proper tail recursion.
Yes.
Yes,
It calls for it. Doesn't know who.
Right. Yeah. So ES6 is going to. So tail recursion is the idea that you can. Well, I'm going to just really simplify it. Tail recursion is the idea that you can create essentially an infinitely repeating recursive loop that calls itself over and over again without crashing the stack. That's the idea. How that's implemented and what it really means for your code is another thing that could probably take a whole topic. But for those types of things, we don't really have an answer yet for it, but tail call optimization or tail recursion is coming supposedly in the ES6. ES2015, we'll see. So anybody else, any questions? We have time probably for like one more.
If not.
And everybody's leaving, so thank you very much.